Hey everyone, note 6.2 are on zero and negative exponents. So the directions say to complete the following chart and evaluate each to standard form. Leave as whole numbers or fractions. So in other words, we don't want any decimals at all. So if you notice in the first question right here, it's 2 to the power of 3, which means 2 times 2 times 2, over 2 to the power of 1, which means just 2. And if you notice right here, these 2's cancel, so we're left over with just 2 times 2, and that's how we get 4. Okay? Using exponent laws, when we divide, we just subtract our exponents. So 3 minus 1 is 2, so I get 2 to the power of 2, which is 4. Okay? All right, so let's take a look at the next one that we have here. So our next one that we have is 2 to the power of 3, and we know 2 to the power of 3 means 2 times 2 times 2, and this time it's over 2 to the power of 2. So I've got 2 times 2. This time, 2 sets of 2's cancel out, so we're left over with 2 to the power of 1, or just 2. Okay? Now, using exponent rules, it would be 2 to the power of 3, and then I'm going to just subtract my exponents, so 3 minus 2 is 1, so it's 2 to the power of 1, which is just simply 2. All right, so now here's where we need to be really careful. The next one that we have here is 2 to the power of 3, so I'm still going to say 2 times 2 times 2 over 2 to the power of 3, so I've got 2 times 2 times 2. And we're going to have things cancel out, but anything divided by itself is essentially just the number 1. So like if I were to divide 10 by 10, I get 1. If I were to divide 20 by 20, I'd get 1. Here I'm dividing 2 to the power of 3 by 2 to the power of 3, and I get 1. Okay? So let's use our exponent rules for this. So I get 2 to the power of 3 minus 3, because both exponents are 3's here. So I get 2 to the power of 0. And we still will get the same answer. So we can see that 2 to the power of 0 is just simply 1. All right, and what we're doing here, these 3 right here, are really important to make sure to understand what's happening here. Okay, now for the next one that we have here, we've got 2 to the power of 3, so 2 times 2 times 2 over 2 to the power of 4, so 2 times 2 times 2 times 2. This one's a little bit trickier because these 2's cancel, these 2's cancel, these 2's cancel. I'm left over with 1 on top and 2 on the bottom, so I actually end up getting 1/2 as my answer here. Okay, so we end up getting a fraction. Now, let's go ahead and do our subtraction. So this is going to be 2 to the power of 3 minus 4. And here, when I do 3 minus 4, I actually get a negative. So this negative exponent right here is really important. And we know it's the same answer as what we have here. So we know that our answer is 1/2. And we'll talk about why that is, or what happens here in a second. Okay? All right, now for our last one, we've got 2 to the power of 3 on top, so I'm going to do 2 times 2 times 2, and in the denominator, I'm going to do 2 times 2 5 times. Okay, and if you notice here, 2's cancel, 2's cancel, 2's cancel, so I'm left over with 1 over 2 to the power of 2, because there's 2's being multiplied together left over, but in the denominator, so I get 1 over 4, because 2 squared is 4. Okay, so let's go ahead and do our subtraction for this guy right here. So it's 2 to the power of 3 minus 5. So we get 2 to the power of negative 2, and if you notice, it's still a negative exponent, and we end up getting 1 over 2 to the power of 2, or 1 over 4. So you should see or notice that when we have a negative exponent, it means that we have to put the base in the denominator. So that's really important, okay? So the next question is, how is the exponent law expression related to the expanded form expression? So how are all of our answers in expanded form related to using exponent laws? You get the exact same answers. So we're going to say here the answers are the same. Okay, and then it says, what do you notice about the result of an expression with an exponent of 0? So that's this one right here. We got an exponent of 0 here, and we ended up getting 1. So let's try another number right here. So I'm going to type in 9, raise that to the power of 0. So 9 to the power of 0 right here, and I end up getting 1. I'm going to take pi, raise that to the power of 0. I end up getting 1. I'm going to take negative 72, raise that to the power of 0, and I still get 1. So it doesn't matter what number I'm taking to the power of 0, I'll always get 1. So I want you guys to write down, please. The answer is always 1. Always, always, always 1. Okay? And then what do you notice about the result of an expression with an exponent that is negative? You end up getting right here, so this right here was 2 to the power of negative 1. It was 1 over 2 to the power of positive 1. 2 to the power of negative 2 was 1 over 2 to the power of positive 2. So you always end up getting 1 over your base to a positive exponent. Okay? All right, so let's talk about this right here. The 0 exponent. Any number or expression divided by itself is always equal to the number 1. Always. Okay? So if you look right here, I'm dividing 2 to the power of 3 by 2 to the power of 3. I should get 1 as my answer. Okay? But let's use the exponent rules. So when I divide, I should subtract. So 3 minus 3 is 0. So I get 2 to the power of 0, which I still should get the same answer, so I end up getting 1. So like we know, anything to the power of 0 is going to give us 1. Okay? For our next one right here, 3 to the power of 2 divided by 3 to the power of 2, we get the same number on top and on the bottom, so they're the same answer. So I should get 1. But let's use the exponent rules. 2 minus 2 is 0, so 3 to the power of 0, I still get the same answer of 1. All right? And then our last one that we have here is x to the power of 4 divided by x to the power of 4. It's the same thing divided by itself, so I should get 1. But when I subtract my exponents, I get x to the power of 0, which is 1. Okay? So therefore, any base raised to an exponent of 0 is always, no matter what, going to be equal to the number 1. Okay, so let's write out a to the power of 0 is equal to 1 right here. Now let's take a look at some examples, because some of these are a little bit trickier. Okay, so here, all of 7 is being raised to the power of 0. So 7 is my base. It's being raised to the power of 0, so my answer is 1. Okay, here, all of x is being raised to the power of 0. So the entire base is being raised to the power of 0, so my answer is 1. Okay, this one's a little bit trickier because this one is, the only thing that's being raised to the power of 0 is this 2. So this is a 1, but I copied down the 3, so 3 times 1 gives me 3 as my answer. Okay, and then in this last one, this one right here is just a 1, but there still is a y, so 1 times y gives me y. So if the other pieces are not being raised to the power of 0, you keep them. They don't become a 1. Okay? So essentially, this is just saying 3 times no zeros. Well, there's a 3 left over. This is essentially saying no x's times y. Well, there's a y left over. Okay? So now we've talked about the 0 exponent. Let's take a look at what happens with a negative exponent. So any base raised to a negative exponent is equal to the blank of the base. It's equal to the reciprocal. And just a reminder that reciprocal means that you have to flip the fraction. So it's equal to the reciprocal of the base raised to the same positive exponent. Okay, so these two things that we're going to write down are really important. So if I have a to the power of negative m, I'm going to take the reciprocal of my base, so it's 1 over a to the 1 over a, and then this negative exponent becomes a positive exponent, so it's a positive m, okay? And if I were to look at the opposite, so if it's 1 over a to the power of negative m, right here, then I would do the reciprocal of 1 over a, which is just a, and then I get a to the power of positive m. Okay, so the next question here says to use exponent laws to simplify each of the following, then evaluate in standard form. So when we divide, we need to subtract our exponents. So I get 2 to the power of 3 minus 4, so I get 2 to the power of negative 1. But because our exponent is negative here, we're going to do the reciprocal of the number 2, which is 1 over 2, and I'm going to raise this to the power of positive 1, so my answer is 1/2. And that should make sense to you because 2 times 2 times 2 is what we have in the numerator. And then 2 times 2 times 2 times 2 is what we have in the denominator. And the 2's cancel out, so I'm left over with 1 over 2 is my answer. Okay? All right, so for our next one here, when I divide, I should subtract my exponents. So I'm going to do 2 minus 5, which is negative 3. So right here, I end up getting 1 over 3 to the power of positive 3, because I just do the reciprocal of 3 over 1. So I end up getting 1 over, now to do this right here, I'm going to do 3 times 3, which is 9, times another 3 is 27. So my answer is 1 over 27. Okay? All right, and then the last example that we have here is 4 to the power of 5 divided by 4 to the power of 7. So I need to subtract my exponents, so I get 4 to the power of negative 2. So I'm going to do the reciprocal of this number, so I get 1 over 4 to the power of positive 2, because don't forget it becomes a positive exponent. And then 4 to the power of 2 means 4 times 4, which is 16. So I get 1 over 16. Okay? All right, so now let's take a look at what we have here. We've got a few more examples. So it says simplify and evaluate. We're really making sure you really get this stuff right here. So this right here has a negative exponent. I'm going to make it a positive exponent. So right here, this I'm going to do the reciprocal of 7 over 1, which is 1 over 7. The negative exponent becomes positive, so my final answer is just 1 over 7. Okay? For the next one here, my base is negative 8, so I'm going to do the reciprocal of 1 over negative 8. The base stays as a negative 8. The only thing that changes is this negative 2 to a positive. So this is the only sign changer. The negative 8 stays negative 8. Okay? So then right here to figure this out, I would do 1 over negative 8 to the power of 2 means negative 8 times negative 8. Which is positive 64, so my answer is 1 over positive 64. Okay? For the next one, I've got 2 to the power of negative 3. So here I've got 1 over 2 to the power of positive 3. And 2 to the power of positive 3 is 2 times 2 times 2, which is 8. So I get 1 over 8. Okay, and then the last one that we have here, remember the base stays the same, so it's still negative 3, and then this negative 3 is the only thing that changes to a positive. And to figure out that answer, I do negative 3 times negative 3 times negative 3, which is negative 27. So my answer here is 1 over negative 27. Okay, so now we want to complete the following table. So exponent form, here, exponent form, I'm going to take this and I'm going to expand it to simplified form here. So 3 to the power of 2 means 3 times 3, which is 9. Okay, this one right here, I'm given the simplified form, and I've got 1 over 5 to the power of 1. Okay, so that means that this 5 is being raised to the negative 1 power in exponent form. For the next one, we've got 10 to the power of 0. Anything to the power of 0 is just 1, so my answer here is 1. Okay? For the next one, 3 to the power of negative 3 means 1 over 3 to the power of positive 3. And 3 to the power of positive 3 is 27, so my answer is 1 over 27. Okay? In this one right here, it's 1 over 3 to the power of 1. And because it's in the denominator, I'm going to rewrite it in exponent form and say it's -1. For the next one, it's 2 to the power of -n. I've got a negative exponent, so I'm going to do the reciprocal of 2, which is 1 over 2, and make this to a positive n. This time I'm working backwards. My base is 5 right here, but I did the reciprocal of it to get this positive m here. So that means that the reciprocal of 1 over 5 is just 5, and it'll be to the power of -m. Okay? And then in our last one here, anything to the power of 0 is always going to be 1, so my answer here is 1. Okay? All right, a few more examples, and then we'll be good to go. So simplifying expressions, the rules for positive exponents also work for 0 and negative exponents. So continue to follow the rules for order of operations or BEDMAS when simplifying and evaluating. So right here, simplify and evaluate the following. So the first thing I'm going to do is, because it's multiplication, I'm going to add my exponents. So 3 to the power of 3 times 3 to the power of -5 becomes 3 to the power of 3 plus -5. So I get 3 to the power of -2. Now, because I have a negative exponent, I'm going to do the reciprocal, so it's 1 over 3 to the power of +2, and 3 to the power of +2 is just 9. So my answer here is 1 over 9. Okay? For the next one, right here, I have -2 to the power of 3 divided by -2 to the power of -3. So my base is going to stay the same, and when I divide, I need to subtract my exponent. So I'm going to take 3 minus, now be very careful, -3. So this minus and negative turns into a positive. So right here, I end up getting -2 to the power of +6. So to figure out that answer, I'm going to do -2 times itself 6 times. Okay, so -2 times -2 is going to give me 4, and then 4 times -2 will give me, so this gives me 4, and then 4 times -2, I'll end up getting -8 right here. And then when I multiply -8 by another -2, I get +16, times another -2 gives me -32, times another -2 gives me +64. So my answer here is +64. Okay? But another way to look at this is, if I have -2 to the power of 3 divided by -2 to the power of -3, this means that I get -2 to the power of 3, because this is in my denominator and it has a negative exponent. I can now put it in my numerator and have a positive exponent, and that's how I get -2 to the power of 6 again. All right, and then our last one right here, the first thing I'm going to do is I'm going to subtract my exponents because I'm dividing. So I'll get 3 to the power of -2, and then I'm just going to copy down this +2. And then when I have a power raised to a power, I multiply my exponents. Well, this turns out to be 1 over 3 to the power of +4. So to figure that out, I'm going to do 3 times 3 times 3 times 3, and I know 3 times 3 is 9, and 9 times 9 is 81. So I get 1 over 81, and that's my answer for this question. Let me know if you have any questions. Good luck with your problem set. Have a great day.